All right, so I now need to say it. Deumbrellization, this overly complex word, symbolizes overgrown umbrellas that we sometimes need to deal with. And today I'm going to propose a solution how to split them into microservices using not so much effort. So my name is Artur Sulej, and have a seat if you don't already. So first, why? What do we gain with the solution that I'm going to propose? So we're going to get most of the advantages of microservices. We can get independent applications, which are easier to develop, which are easier to scale. Because, for example, like in machine learning example, some parts can require a lot of more resources than the other parts. So if we have separate runtimes, we can adjust those resources for the needs. And none of the parts will stay hungry. With smaller apps, we get faster compile time. We can also get some perks in local development because if we spread the apps across multiple nodes, we can plug in our local node instead of like remove one brick and put our brick, which is a node that is run locally. And my solution also requires less effort than using other like more widely used solutions like gRPC or implementing HTTP endpoints, etc. First, some recap what Umbrella actually is. It's a way to structure Elixir project. It has some specific features. We have in Umbrella sub-applications, like here. Here's an example, actually, it's an example of a simple Phoenix app that has two apps. One is responsible for web interface and the other holds business logic. Apart from that, there is one config that holds all the stuff for all of the applications, and also in mix.exs files there are explicitly stated dependencies between those applications. I'll just show it in my code as an example to make sure we are on the same page. Thank you. So here's a simple Phoenix application. It's a controller with.
Can you make it like a little bit bigger?
Sure.
Small.
Yeah. So it's typical controller from Phoenix application. We've got our index that invokes function from the other application. And this dependency is stated in mix.exs file over here. I guess you can, here, in Umbrella true. And we've got our config that holds stuff for both apps, both for To-Do and for To-Do Web. Right? So to split such Umbrella application, we need to get rid of those in-Umbrella dependencies. we need to separate those configs to separate files, and we also need to do some adjustments to mix files. So these three first points are quite simple usually, quite boring, quite simple stuff. We just need to do some config work and to make it work. And the real fun begins with tackling communication, because the code from the other application is no longer just available locally, so we can't just invoke it just like that, like in this controller example. We need to take care of the communication over the network, because both applications are going to be run on separate nodes, so separate runtimes. And what actually is a node? It's just an instance of Erlang virtual machine, and nodes can communicate between each other. There are certain mechanisms that are ready to be used to make them talk to each other, and basically they form a distributed system together. And here's a simple tutorial-ish example how to connect two nodes. These are just two tabs from terminal and two interactive Elixir sessions that are started. We need to give them names, and then, as you can see, first if we try to see what's in a list of connected nodes, the list is empty. When you connect it, it appears here and on the second node as well. So two nodes are connected. So that was a simple example, but apart from being simple, it was also very manual. You may ask yourselves, like, how to do it on production, how to do it in real life. So the answer is libcluster, which is a really great library that does exactly that, but automatically. And all you need to do is to use this supervisor that is provided by this library, and something that is here called topologies. Topologies here are basically it's basically configuration that says how those nodes should be connected, how to discover them, and how to connect them. In this case, this example, you can see local EPMD, which is very useful for local development, because what it does is it automatically discovers all the nodes that are currently run on the local machine, on local host, and just connects them into a cluster. And if a new node appears, it's automatically added. So that's pretty much all you have to do to make it work locally. So we got to the point where we've got our nodes connected, but we still need a way to send messages between them, to make them talk to each other. So again, we've got a mechanism that is ready out of the box, which is RPC module from Erlang, and it basically works like on this example in terminal. You can use RPC call, pass the full name of a node, and then three other arguments are module, then a name of function, and a list of arguments this will be run on the other node, and on this node we'll get a result of this invocation on this local node. So back to our example with controller. I'm not sure if you can see it, but it's a div what changed. So instead of just simple invocation of locally available code, we are calling RPC call like that, and it makes it work. However, in my opinion, this looks a little bit ugly. So maybe we can make the developer experience a little bit better and make this code look a little bit more like the original one. So we can add some syntactic sugar and use macro for this purpose. So on a side note, what is macro? It's a way to do metaprogramming in Elixir. What is metaprogramming? So basically, when you write normal code, it does something, but when you do metaprogramming, you write code that does something. So I hope that makes sense for you. So in Elixir, we've got macros. And how they work is that you write a piece of code that is run not during runtime, but during compilation time. During that time, there is an intermediate step where AST is created, and AST is abstract syntax tree. Which is a structure. Basically, our code that is at first the text is converted to a structure that is. I think that the example will explain it better. Basically, we've got invocation of this macro here, and this piece of code gets transformed to this first line that is commented. That's how it looks. So I'd say it's semi-human readable, but it's perfectly fine to be parsed. And for that purpose, we can use just pattern matching. So in this case, what we need to fetch from this data is this module name, here represented as a list of atoms. We need name of function, and we need arguments, which are probably here. In this case, they are empty. So we use pattern matching to take this out of the structure. We need to slightly transform this module to match what RPC call needs, and we put this stuff in RPC call, and you wrap it into quote do. What quote do does is it creates AST basically from this code here, because what macro does is it operates on AST, and the result of it also needs to be AST. So here it looks like we have a code, but underneath this code is transformed to AST, and during compile time, and macro transforms this AST to any AST that we like, and in this case, RPC. So from this point, it looks like this, but underneath we've got this old RPC call. We can extend our macro further. and we can add, for example, some handling of errors. And what's more, RPC call requires us to pass full node name. But here I added some logic that uses node list to fetch all the nodes that this node is connected to. And then it filters out one more thing. We can pass, here we're passing not the full name of the node, but for simplicity and for ease of use, we're passing the short name. So, and this piece of code filters, finds the full name of a node in the node list based on the short name passed here. Yeah. So, so that's pretty much it. We've got our umbrella split. We've got our nodes connected to each other, and we've got communication between them, so they can send the calls between each other. So the question is, does it really work? And I'm going to prove it now that it does. So here's a simple Phoenix app. And as a recap, I will show you how it looks now after all those changes. So we've got our controller that uses this macro, and macro has this piece of code as an input that gets transformed. This is our macro. What's more is that our apps are split in a way that there are no longer in umbrella dependencies between them. Also, the config is split. Like in to-do web, we've got separate config. In to-do, we've got separate config, and only stuff that belongs to the given app. And we've got our config for libcluster, which is this supervisor that uses topologies. Yeah, one more thing is that I moved this topologies to a dev config because it's perfect for local development. In case of production topologies, they would probably be different, and they could be put in prod as well, etc. So this is how it looks after all those changes. And does it work? Let's find out. This is our...
Could you please increase the font size?
Yeah, sure. So we are in both applications. Let's run just web, for example, for now. So running Mix Phoenix server, but in a way that allows me to set name to this node. And it doesn't work as expected because the other node is not run currently. And our code in macro made this raise this error. So what happens if we add the missing part? here, notice that it's not Phoenix application. It's just a plain Ruby. Plain, oh. Yes. It's like using the name of your ex on the first date. Never happened to me. Plain Elixir app without Phoenix. It's now run. I had to add this no halt option so that it doesn't finish after executing it, so that it stays on. And the moment of truth is that we've got our application. So I can add something, and it works. And both apps communicate. Woohoo! All right. So, what about tests? Because this transformation makes it a little bit more troublesome. So I can see a few approaches that we could take. We could simply run the nodes that our tested node depends on. So that's quite a simple approach. We could also create different implementations of those dependencies. Some simpler ones that have, for example, hard-coded data, and because of that they're faster and build faster, etc. But so it has some advantages, but on the other hand, it's a bit more effort. Another approach is that we could extend our macro further and do something like that. We could check. Oh, make it bigger again. We can check our environment. Sorry, I should start from the other file. So we could do something like this in our macro. We could check if it's test, and for test, take the data from the process registry, and in the test we can put whatever value we want. So basically we could create mocks this way. So in this case, yeah. Instead of this test, instead of calling another node, it puts some data into process registry, and this macro fetches it. At the same time, it deletes it, so that it's empty for other processes. I mean, not the other processes, but other tests that use the same process. So that's another approach. And yet another one is to... at first I mentioned that we need to remove the in-umbrella true dependencies from mix files. But actually we could do something like that and leave it, but only for test. And this way this code would be available. We would still have Umbrella just for tests. So, and again, we would need to do some changes to the macro. So basically, when running the application on production or in development, we would have separate nodes, but in tests, we would have still an umbrella, and the code would be invoked locally, just like before. So that's a very simple approach with I think the least effort needed. But on the other hand, we lose some perks for local development that we would normally gain with this approach. I mentioned what we get, why to use it. It would be fair to mention why not. So first thing is that we get no isolation between the nodes because RPC allows us to call functions, any public functions from any connected node. So in some cases it's not really a problem, but there are some cases where we, for example, allow users to run something on our nodes. So it depends on how much control you want to have over it, and plus some security reasons, etc. So it depends. On the other hand, this situation is not really worse than using Umbrella because it's the same there. You can call whatever you want from the other app. Another thing is that this solution is only available for Elixir and Erlang. Because as a contrary to, for example, gRPC, which is more widely spread, more generic, and technology agnostic, actually it's not for those technologies only, because underneath there are some protocols that could be implemented in other languages, and actually there are some implementations, but I believe in practice it's not so available. So it limits our ecosystem to those technologies. And a bunch of interesting resources that I would like to share with you. First is it's an article from Anton Misztuk. This article was an inspiration for this talk for me. Another one is also a very interesting article written by Karol Słuszniak about his pet project, his side gig. Also very interesting, definitely recommended. And if you want to check libcluster, here's the link for the docs. If you want to see, for example, what other strategies are possible. And that's it. So thank you.
One, two? One, two? Okay, I'm online. Thanks, Artur, for the talk. Thanks a lot. It was very inspiring. I'm going to put the lights on because it's too dark. Okay, that's better. We can dim it if we need to show the code. Do we have any questions for Artur? Koshik, okay.
Thank you, Artur, for the talk. Really nice presentation. I have a question about using this approach as a first step to extract it to fully independent microservice, because you didn't mention what happened with database and what happened with coupled logic. So what do you think about using this approach as a first step, just for making, the kind of local development a little bit easier at the beginning, and then step by step removing these dependencies and moving to real gRPC calls and real Kafka events or whatever.
I think this macro that I showed would be helpful. Probably. I'm not sure if it would be a good idea, but here, I'll get back to it. Here. Just everything the lights. Under the lights, man. Quickly ask question. Nice. Yeah. So relaxing. So we've got this macro, and here it generates this code that is RPC call. I guess we could change this macro to generate different code and put code that makes gRPC call. So that would be nice in a way that we wouldn't have to change this logic in controller, right? It would just change underneath. But on the other hand, it's a bit magical. So I don't know. That's one option.
Kaushik, does that answer your question? Partially.
Thank you.
Want to follow up? No.
I will ask it.
Okay. Cool. Anyone has any other question?
Yeah,
Okay.
so I can speak loudly, maybe.
Okay, I'll repeat it.
Lead cluster, how well it behaves with graceful shutdowns. So if you have service under load and the service you are calling is trying to shut down, how well it's handled with the lead cluster.
Okay, so I'll repeat the question. So lib cluster, how well does it behave during graceful shutdown? So when the service is under load and it needs to shut down, how does it behave? How does it work with that situation when a node is exiting, like shutting down, and it needs to be disconnected, right, from the from the cluster?
I'm not sure, to be honest. But I think there is. Let me try first. I think there is connecting nodes means that there is one connection that is open. So if it's broken, I think the other node that still stays up should be aware of it, I guess. And yeah. So it will disappear from this node list.
Yeah, libcluster only does service discovery. It tells you where the nodes are and connects them, but that's it. Then libcluster is out of equation. So if you want to have graceful shutdowns, then you need to add a layer on top of it. So for example, something that you can do is that Erlang has this module called PG, which is a process group. And what you can say is that instead of me doing like calls into the other nodes and assuming that they are available and they are up, I'm going to register the nodes on PG and say, look, I'm providing this service, and this service. That's one approach that you can do it. So it's more like, and then you can do routing. You can pick any node randomly. And then what you do is that when you are going to shut down, so the shutdown, every time you're going to shut down your application, it goes to the supervision tree and shuts down the processes in the opposite order that they are started. So what you can do, a trick is to have a terminator process. Is a process that you have it at the last of your supervision tree. And the only thing that it does is that it waits for it to shut down and for like your application to shut down. And when it shuts down, it executes some logic. So there are a couple of things that you could do. So for example, what you could do is that you could call node disconnect, and it just disconnect for everybody you are connected. But you can also exit the process groups that you are currently in. So long story short, like it's not part of a libcluster when it comes like you are doing distributed communication and you want to deal with shutdowns, then you have to consider that particular aspect.
Awesome. Thanks for the answer. Cool. Do we have any more questions? No? Yeah? Okay.
So thank you for the presentation. I have a rather quick question regarding the benefits it brings, because from my point of view, it could be possible to use that approach with the Umbrella app. So just simple start two different nodes with the same code using the Umbrella app, and these RPC calls would still work, right? And just with the Umbrella app, we have a choice to either run it locally in the same process, like a function using the remote macro, and also we can run it as an RPC call. And when we make this like separation of these projects into, I don't know, different repositories, for example, we don't have this choice. We need to run RPC. So it's rather for organizational purposes. Simply, it might be easier to scale the teams or like separate the responsibilities. But maybe it could be the same. I'm not exactly sure how Umbrella Apps behaves when you, for example, don't define the dependency of one app in the another. Maybe I think that such a call of like starting a function in another application would be also prohibited. So what are the clear like benefits of doing it this way instead of keeping it the Umbrella app and maybe introducing the macro you showed to us?
Mm-hmm. So if I get it right, you mean having separate nodes, but they would be the same pretty much. Like I think it's called homogeneous nodes. So I guess some things would be simpler, but on the other hand, you still have like this rather monolithic applications, right? So you got all the code in one project, which, for example, makes longer compile times, right? Like that's the one argument I can see, and basically you get. To me, it's quite similar, like monolith between versus microservices, like apart from Elixir.
Chris? Do you want to voice it?
I don't know if it's educated enough to voice. There's a huge benefit to code ownership and a huge benefit to a team owning a certain code base and being able to run it completely independently.
Say it on the mic.
I think there's a huge benefit to teams being able to move and work independently. So having a separate code base and it's completely isolated and saying this is mine, I own this, I can better it, I can make it work, is like not thinking about that thing is like a shortcoming of a lot of engineering structures I've seen in the past. So if you could have it isolated and you get pure code ownership and you get someone that owns it and makes it better over the course of time, then the code structure is reflecting the organizational structure. And if you don't have a one-to-one relationship between that, you end up with a shit show of either code that's going all over, you're trying to develop features and you need 3 teams to do it, or you have a single, well, basically that. You have 3 teams that are trying to develop one code base and you need to intermingle all the teams in order to make it work. So yeah, that's my strong opinion that might be uneducated.
All right. I think so. What I'm hearing is there's more arguments for actually splitting it instead of keeping it in one place. But yeah, we can discuss later. I think let's wrap up this one so we can take a short break and we have a third talk. So let's hear it again for Artur.
Thank you.